before we get to understand definite integral, we need to understand first this what we call the Riemann sums. And just to give you a background, or let's just have some sort of review of what is this indefinite integral. So remember when we had this, the integral of f of x dx, we can always rewrite or write the answer to this as an equation f of x, which is the antiderivative, and then we add the constant of integration. But if we have, let's say, the same function f of x dx, but in this case we just want to integrate them between a to b, within of course the domain, and assuming that this f of x is a continuous function between this interval. So therefore the answer should be given as if we have this antiderivative, and then we have to substitute the value of b to that function and then subtract the same function upon substitution with a. And then of course we don't have any constant of integration because we know very well that this gives you a certain value. So this one is the indefinite because it simply gives us the equation, and then this one is the definite because it gives us the value itself. Now, what is the essence of these two equations in dealing with the Riemann sums? So, again, pag sinabi nating Riemann sums, we're talking about the sum of all the partitions that can be incorporated in terms of a subinterval. So I'll be going to the handout and just to give some sort of explanation regarding these Riemann sums. So right now you're seeing your handout, and let me just discuss things out here. Now Riemann sums, if we have an f at a function defined by the on the closed interval ab, and we let this delta be a partition of ab, then we can say that a going to B will have a lot of interval in between them. So for example, meron tayong A, let's say -5, and then B natin is 4. So these x values that you can see from x sub 0 to x sub n could be any value in between this -5 to +4. So we call this the subinterval delta x sub I, which is the width of that ith subinterval, wherein we could say that if any point ci in the ith subinterval, so we just can take the sum of that, and then that will be the Riemann sum. So later on I'll give you an example about this Riemann sum. I'll just be discussing things about here and the terms that we should be using. And then pag sinabi natin yung largest subinterval of that partition, so we call that the norm of the partition, and denoted siya by parang double absolute value sign and then yung triangle doon. So if every subinterval is of equal width, that is kung magagawa ka ng subinterval and then same lang sila ng distances from the first point to the second point, then the partition, we call this regular, and the norm is denoted by this expression. So basically you just have to subtract the two intervals, the upper and the lower bounds, and then divide it by the number of intervals that you want. So you'll be able to get the value of the width of the subinterval. Now, if the partitions are not equal, we call this the general partition. So basically, when we try to draw this, we usually assume a general partition. But of course, when we want to solve for the Riemann sums, I mean, it is always a must to be using the regular partition, kasi hindi natin siya masosolve when we don't have any particular value of the width. So the Riemann sums can be calculated using the left endpoint, right endpoint, and midpoints. It can also be averaged. So paano ba tayo nagsosolve ng sinasabi natin na Riemann sums? So let me just go back here just to show you how this left endpoint, right endpoint, and midpoint work. Now pag sinabi nating left endpoint, so imagine if I have a Cartesian coordinate system here. Okay, so this is your xy coordinate. Okay, so you have here y and then x. Okay, so this is your Cartesian coordinate plane, and let's say I have a graph. Let's have this. Okay, and this is my graph of the function. Okay, and then you just have to like take this a and b. So ito yung limits of integration natin. So, meron lang tayong a and b. Of course, yung a would be negative values of x, but in this case, let's just generally refer to this as your a. So, siya yung lower value of the interval, and then b would be the higher value. So, pag sinabi natin Riemann sum, you basically start with the lower limit, and then you try to draw rectangles of the same length, or I mean of the same width. So for example, yung ating ito from A to B, let us partition this in, let's say, n is equal to 5. So in this case, I need to divide all of this in 5 equal partitions. So we'll have a regular partition. So 1, 2, 3. Okay, 1, 2, 3, 4, 5. Okay? So, maganda naman yung ating pagkakahati, no? Though, medyo mas malaki dito. Pero, assume natin na they have the same width. So, when we say left endpoint, you start with the leftmost portion of this curve. So, in short, you start with this lower limit. So, you start with this lower limit when we say we have a left endpoint. Okay. So with this, mag-start akong magawa ng rectangle from this. Okay. I'll try to use a different color just to emphasize the rectangle. Siguro, ito na lang. Or red. Okay. So starting with the left endpoint, so we have this rectangle. And then, what you have to do is to construct rectangles based on this left endpoint that you started. So with this, you project this para makagawa ng rectangle. And then, you move downward naman just to end up with the first partition. So that would be your first subinterval or the first rectangle. Now, how about the second one? So yung second one mo, you look at the intersection of the yung rightmost portion ng rectangle. So this is that one with the curve. And then you try to project it again dun sa next point of your subinterval. So in this case, that's the second one. And then again, you try to check on the intersection, and then you project this to the end point of this next subinterval, and then you project it downward. So you'll be doing that until you end up with 5 partitions. Okay, so with this this one, and then you try to draw something like this. Okay, so though mas malaki ito ng konti, assume lang natin na equal partitions sila. So with this 1, 2, 3, 4, 5, you have 5 partitions. And what Riemann sums do is that it takes the sum of all these, as you can see, all these rectangles. So basically, rectangle lang yung hinahanap. So ano ba yung area ng rectangle na na-comprise nitong ating figure na to? So basically, what we need to do, of course, is to find the area under this curve. Imagine if you have this curve, so all you need to do is to find the exact area under this curve, diba? Yung exact area, as in, wala tayong labis-labis dyan. But as you can see from the Riemann sums, meron tayong mga certain portion outside the curve. Ito yon, tinutukoy ko dito is ito, na hindi sila kabilang technically dun sa area under the curve. So when we talk about integration, we're usually referring to the area under this curve. But then again, what we have to do here is to find the area from this sum of these rectangles. So imagine if you need to find the area of this rectangle, so what you have to do is to simply use the area of the rectangle, and we know quite well that the area of the rectangle is, or any rectangle is length times width. So ano ba yung length nung ating rectangle na to? Say for example, we call this the rectangle 1, so A1. Di ba yung ating length nito, or this one, this height, let's just use height na lang, height times width. So this height, we know very well that this is the value of y when your x is a. So in this case, we could always say that for any area, we could say that this is the value of y when you have this certain value of x. And if, for example, this the equation of your curve is f of x, so therefore the length or the height would always be f of x. Okay, and then how about this distance? So you can just take the difference between these, let's say we have a sub 1 here, and then let's use another letter, let's say C. So the difference between these two would be the width, so that is C minus A. But remember, if we're talking about the distance or the difference between two values of x, we can simply say, or roughly estimate, that between two values of x, we can roughly estimate that this is the value of your dx. That's why we could say that this boils down into this f of x dx. Kaya kung mapapansin nyo, it's just the function multiplied by dx. Okay, and then we will be doing this for a2 as well. So a2 is equal to f of x dx. Okay, di ba yung dx naman is fixed lang, pero itong f of x depende to dun sa value nung x mo dito. So pwede sabihin natin this one is x sub 1, this one is x sub 2, up to the point we have a sub n, which is equal to f of x sub n and then dx. Okay, so knowing this, and then we have to take the sum of all these areas. So from a1, the sum of a1 to let's say to the n. So this is typically equal to dx, and dx, we know very well that this is the distance between these two x values, and we know quite well that this delta x based on the handout is given by b minus a divided by the number of partitions. So in this case, we could say that we can factor out dx from this expression. So we have something like f of x sub 1 plus f of x sub 2 up until f of x sub n, and then we multiply this with your delta x or dx. So this is a rough estimate, no? So this is times b minus a over n. So basically, what I want to tell you is that this dx is actually infinitesimal value of your x sub 2 and x sub 1. Kasi remember, if I try to make the partition smaller, let's say hatiin natin siya into 10. So yung n natin gawin natin siyang 10. So 'di ba, instead of having this, dito lang siya matatapos, no? Sorry. So dito lang siya matatapos. And then basically I will try to do this again here, and then this one is from here, and then so kung mapapansin niyo yung pattern nito, 'di ba mas naging mas accurate siya as we have dx, as we approach dx into let's say dx approaching to 0, or not 0 but literally very small value. So as this dx approaches to 0, we can say na ang ating area ay mas naging accurate. That's why our goal is to make this dx approach to 0, and as our number of partitions increases, then yung ating area becomes more accurate. And up to the point when n approaches to infinity, we could say that this is the exact value of your area under the curve, because that's basically what what definite integral is all about. But before those proponents arrive on that a certain equation, they used to understand this as yun nga, partitions of several rectangles. So by the way, going back to this, I hope malinaw na kung ano saan nangyari yon, yung sum ng mga rectangles na yon, and we'll try to devise yung ating equation here. Okay, so let's just denote our Riemann sum as the summation of I sub 1 going to n, and then this one is f of c, or let's say x. So that is something like x sub I, and then of course delta x sub I. Okay, so knowing this, we can simply substitute the values of that. So or let's just use this let's say Riemann sum. Okay, so let's just have this, the Riemann sum is equal to something like this. Okay, so with this, let's try solving for an example of this. Pero bago din sa handout, let's give numerical values ito para mas magets natin. So halimbawa, this one, let's say hindi na siya a, kundi bigyan natin siya ng values. So ito, let's say a is negative, based naman dito sa figure makita natin is this one's negative 3. Okay, 1, 2, 3, and then this one is also positive 3. So With this, we know very well na yung ating delta x, we can compute for that. So that is 3 minus negative 3. So that is plus 3 divided by number of partitions. We have 1, 2, 3, 4, 5. So 5. This gives us 6 over 5. Therefore, from this negative 3, what could be the value of this one? So that is negative 2 and then negative 1, 0, 1, 2, 3. So basically, kasi 1 unit lang naman sila. Pero yung delta x mo should be this value. So with this, the Riemann sum is equal to, we have first yung length nito, and we have to take this equation of f of x, then substitute the value of this, which is negative 3. For example lang, though this is not the equation itself, but let's have it assuming na this is actually equal to x cubed minus x squared plus 1. Siyempre, hindi talaga yan yung ano yan, hindi talaga yan yung equation niya, no? Or let's say plus 3. Plus 2 na lang. Okay, so as you can see, our delta x is equal to 6 over 5, which is equal to 1.2. Now, this figure, kung mapapansin nyo, parang doon ako nag-stop mismo sa H1 unit. So basically, medyo mali yung drawing dito sa portion na to kasi dapat it should have been medyo ganyan kalalayo, no? Para magsakto siya doon sa ating equal partitions sa ating 5. But anyway, we need to find points. We need to find points here na magko-correspond dun sa ating mga x values dito, 'di ba? So kung unahin natin ito, alam naman natin na negative 3 siya. So how about the second point here where this rectangle ends? So if we try to do that, we can just have this negative 3 and then we add 1.2. So with this, the value would be around negative 1.8. So that will be negative 1.8. So therefore, this portion here would be negative 1.8 instead of negative 2. Medyo nagsakto lang siya dun sa negative 2. Okay, so kung gusto nyo, actually we can write that, each of them, from x sub 1 to x sub 3. So, I mean, to x sub n. We can say, for example, yung ating x sub o, kasi yun yung lower limit. So we start with negative 3, okay? And then yung ating x sub 1, actually this should be start tayo sa x sub o and then 1 tapos n. Anyway, kung 1 naman in-start mo dito, you can just use 1, 2, 3. Basta mag-start kayo dun sa pinaka left endpoint, which is your your lower limit. So how about x sub 1? So kanina pinakita ko sa inyo that will be negative 3 plus 1.2, which gives you negative 1.8. Okay, how about x sub 2? So we're moving from left to right na. So this is negative 1.8. So how about this one? So you have to add again negative 1.8 plus 1.2. So this, I think, gives you a value of negative 0.6. Okay, so negative 0.6. Now how about x sub 3? So x sub 3 should be negative 0.6 plus 1.2. So this gives you positive 0.6. Okay, and then x sub 4 should be 0.6 plus 1.2. This gives you 1.8, and then x sub 5 should give you 3. So kailangan mapansin nyo na ganito yung mangyayari sa kanya. You start with the lower limit, negative 3, and then you end up with the upper limit, which is equal to b dun sa sinet natin, or sinet nyo na interval. But when you try to count all of these x values that you have, you should be having something like n plus 1 number of x values. Kasi diba 1, 2, 3, 4, 5, 6. All in all, we have 6 of them. Kasi this one kasi is in-incorporate natin lahat ng endpoints. So imagine kung meron kang 5 partitions and nag-adjacent yung 3 na yon, pero syempre yung dalawang dulo dyan, so additional pa yun, kaya magiging 6 yan. But ano ba yung essence nitong 6 na to? Bakit sinasabi na may 6 na may n plus 1? 5 lang naman yung kailangan natin. So, diba, what we'll have to do here is to find the area of each rectangle. So, let's try doing that, no? again, yung ating delta x, which is the distance between these two ends, nakuha na natin, that is 1.2. So, wala tayong problema, no? For example, we have a sub 1. So, ano ba yung area ng ating a sub 1? So, dito, we could say that we have f of x sub o, and in this case, that will be negative 3. And then, we multiply this with our delta x, and that is 1.2. So, yun yung ating area sub 1. So, ito yun yung area 1. Ito yung gagawin natin formula. And then, a sub 2. So, we have here f of, instead of using negative 3, so hindi negative 2 kasi syempre hindi siya saktong 1 unit. So we have 1.2 units. 1.2 unit. So with this, instead of using negative 2, you use negative 1.8. So that's negative 1.8. And of course, yung ating distance or yung width ng ating partition is just 1.2 as well. Okay, so ganyan nagsosolve ng ating Riemann sum. And then plus ulit natin yung area 3, which is actually equal to, yung ating area 3 is f of, so, f of, ano naman siya? F of x sub 2. So, that is f of, saan na ba ako? Negative 3, 1, negative 1.8, 0.6. So, that is 0.6. And then, you add, you multiply this with 1.2. So, ganun lang yung ating, mangyayari sa atin na solution. And then, A4, so, area 4 is equal to f of, I think this one is negative 0.6 and then this one is 0.6. Okay. And then lastly, we have a sub 5 is equal to f of 1.8 times 1.2. Okay. So, kung mapapansin nyo, 5 na to, di ba? 1, 2, 3, 4, 5. How about this x sub 5? Bakit di na siya ginamit? The reason for that is that we're using the left endpoint. So, huwag nyo yung kakalimutan. Pag left endpoint kayo, kayo mag-start sa lower endpoint ng ating limit and then you end up with x sub 4. So, kasi, di ba? Dito tayo start. So, 1, 2, 3, 4, 5. Kasi ang kailangan mo lang naman is itong distances na to, diba? So, kung makakalima ka na yan, so basically, di mo na to kailangan. Kasi basically, ipoproject mo pa yan doon, papunta doon. Kung halimbawa, isasama mo to, ipoproject mo yan doon, papunta doon. Kaya madadagdagan ka pa ng isang area dyan. So, what you have to do here is to look at this sa left endpoint. So, hanggang doon ka lang, doon sa last value of x before you end up with the upper limit. So, in short, hindi na to kasama, no? So, I think that makes perfect sense when you have the right endpoint naman, no? But I'll show you it later na kapag, siguro nagkakaroon ka idea na pag right endpoint siya, you start with this x to the 5th and then you end up with x sub 1. So, mawawala naman yung x sub o natin. But later on, I'll show you how it is done. But for the meantime, siguro, itry natin tong i-solve further. Though this is not the exact example in your handout, I'm just showing you how it will be done later, no? So, ganun siya. And then, for a sub 1, so nakita natin na kung anong gagawin. Isasubstitute natin itong mga values na to dito sa equation natin. So, we have a sub 1 would be negative 3 cubed minus negative 3 squared plus 2. And then, you multiply this with the width, which is 1.2. So, ito yung pinaka-a sub 1 natin. Okay? So, this is, I think, negative 27 minus positive 9. So, we have negative 27 minus positive 9, okay, plus 2, and then times 1.2. Okay? So, with this, ang ating sagot is, so, negative 40.0, negative 40.8. So, don't mind yung muna yung sum, basta you just try to find the area kung ano man makuha nyo, might be negative or positive. So ganun lang siya, and then you try to add off all of them, and then that will be your area. So with this, I'll try solving for the one in your handout para mas mas detailed tayo. Okay, the integral is from 0 to 10, so yun yung ating lower and upper limit. When we have x cubed minus 2x plus 1. Okay. So, kung gusto niyo itong ma-visualize, you can always try to graph this equation. And then, siguro, I'll just try to use an application to graph this para, mas accurate ako. And then I'll try to draw it or reflect it here. Okay, so now basically this is how the graph will look like. Medyo extremely mataas siya, and this is a truncated version of that graph. Medyo siya na narrow yung ating graph, no? But you can always try to input this in a graphing calculator online or graphing utility sa website. And para mas ma-visualize yun, no? Pero in this case kasi, I will not be using, yun nga, para hindi na ako magpalipad-lipat ng window. So anyway, ganito naman siya. And ang importante lang kasi dito sa atin is para ma-visualize natin siya and then we try to draw yung ating partitions. So, if you start with the left endpoint, so you start with 0 dito. And then, sabi dito kasi, we have 5 partitions. So, itry natin hanapin ngayon kung ano ba yung magiging values ng ating mga x's. So, delta x or yung ating norm would be equal to b minus a all over n, which gives us 10 minus 0 over n, over 5, which is actually equal to positive 2. So therefore, meron tayong 2 units for every subinterval. So ito yung 2 natin na una, and then diba dito siya nag-intersect. So what you have to do here is to just project papunta dun sa 2 na yun. So kung halimbawa, nasa baba yung ating graph below x-axis, so pababa yung ating rectangle. But in this case, since nasa taas siya, so we just have to project. Kahit pa siya ay overestimate, by the way, yung term na overestimate is that kapag lumalampas siya dun sa curve na supposedly area under the curve yung kukunin mo, pero dito nga is lumampas na siya, so you call that overestimate. Pag naman nasa loob siya, that is an underestimate. So anyway, since overestimate siya, wala naman tayong wala tayong concern doon kasi wala ganun talaga yung graph natin, no? And then sabi ko nga, you start again with the intersection of that to the rightmost part. So ito yon, and then you project that with the second line, okay? So hanggang dun lang siya. And then this one, 'di ba, parang underestimate naman siya. And then gagawin mo ngayon is to project that again, punta doon, okay? And then ito naman pupunta doon. Okay? So this is how you do your Riemann sums. Okay? So, hopefully ay okay. So, ito yung ating Riemann sum. So, you can just shade it para mas malinaw. Okay? Pero basically, what we have to do here, so babalik ko na. Kasi parang hindi siya maganda pag may shades. But basically, what you have to find here is the certain area under the curve, which, syempre, ang ating domain kasi is from 0 to 10. So, itong mula dito up until this portion ng 10 here. So, lahat nito. Hanapin mo yan ngayon, yung lahat ng area under niya, no? So, yon. And we'll be employing Riemann sums here. So, with this, we could say that our Riemann sum is equal to, using our general formula na summation yun ng lahat ng mga areas natin, and we have actually 1, 2, 3, 4, 5 partitions. So therefore, for our first area, we know quite well na this one is 0 and then 2, yung ating positive 2 yung endpoint niya. So if we have f of 0, so you can just use f of 0. So we have 0 cubed minus 2 times 0 plus 1. Then we multiply this with your partition, so that is 2. So we call this first, this is our area 1. Okay? How about for our area 2? So for our area 2, we have, diba? So sa 2 na siya nag-start na for your x sub 1. Kung x sub 0 to, then x sub 1 yung sunod. Kung x sub 1, then x sub 2 yung Depende sa designation nyo eh. Anyway, basta mag-start kayo sa left, lowermost endpoint. Lower limit. Ganun. So for 2, we have 2 cubed minus 2 times 2 plus 1 times 2. Okay, and then for the next area, so ito na is our area 2. For the next area, we have positive 4. So we have 4 cubed minus 2 times 4 plus 1 times 2. And then you add 8. So 8 cubed minus 2 times 8 plus 1, then times 2. So we have, I think I forgot 6. So gawin natin itong 6 muna. 6, and then lastly, we have 8 cubed minus 2 times 8 plus 1. So again, bakit nga wala tong 10? Kasi yung 10, hindi na siya kasama kasi we're talking about the left endpoint. So tandaan nyo yun, na pag left, 5 lang dapat to, and as well, kung ilan yung partitions, ganito rin dapat karami yung area nyo. And hindi nyo lagi sasama kapag left endpoint yung pinaka rightmost na limit nyo. So this one is a sub 2, This one is a sub 3. This one is a sub 4. And then ito yung ating a sub 5. Okay. So siguro malino na naman tong ating mga designation kung saan ko nakuha yan. Gumamit lang ako ng equation na given natin. And then I'll try to calculate this. So pag pag pinagsama-sama nyo to, you should be able to get an area. Or pwede nating i-name na lang pala siya as area na lang. Ganun na lang gawin natin, area. Area using the left endpoint. So ganyan na lang. Area using the left endpoint is equal to 1,530, that is units squared. Okay? So this is your final answer for this problem. Okay? So hopefully nasundan niyo 'yun, no? So that is just simply 'di ba, for this alam naman natin na this is 2 kasi ito 'yon. 0 plus 1 and then plus 2, so plus 2, and then plus we have 8 minus 4, that is 4 plus 1 5, so plus 10. Okay, and then plus we have 4 cubed would be 64. Okay, minus 8, so that is 56. So we add 1, so 57, and then we multiply it to 2. So with this, I think we have 114. And then we add again yung 6 cubed. So 6 cubed is 216 minus 12. Then plus 1, so 205 times 2, we have 410. Okay. And then you add the last one here. So, diba, this is 8 cubed would be 512, and then minus 16 plus 1, so 497 times 2, that gives us 994. Okay? And then finally, if we add all of this, that should total 1,530 units squared. So, hopefully nagas nyo yung unang problem na yun. So, madali lang naman siya. It's just that you have to take note of your delta x or your norm. And then, after finding this norm, you have to find all the points na kakailanganin natin for each rectangle. So, start kayo sa pinaka-left end point, and then, for every partition, dun kayo magbibilang. So, dito 2 units. So, 1, 2, then 1, 2 ulit, 1, 2, hanggang ma-reach yun, 10. Pero sa paggamit ng partitions, again, pag left end point, pinaka-left ka, and then you just end up with this, dito lang, bago mag-pinaka-last natin. So, hindi na to natin isasama. So, ganun lang siya for left end point. So, how about for our right end point? So, let's have, siguro, so, ating right end point kasi same lang din naman to. So, siguro babaguhin na lang natin itong mga dito, mga given ng content. So, right end point. Okay, and then, syempre, yung ating partitions, same lang din naman yan eh. I mean, yung number of partitions, saka yung ating width, kasi same lang naman siya. Pero siguro, we'll have a different figure dito. So, ba't kaya ganun? So, I'll just draw the figure again. Okay. So, diba, this is 1, and then this one 2, 4, 6, 8, 10. So, ganyan lang din naman siya. Pero, I want to specify things out here, especially when we're dealing with, with left, or, right endpoint. So, diba, this one is your 10. This one is 10. So, lagyan natin. This one is 10. Ay, sorry. So, ito is 10, and then 8, 6, 4, 2, and then 0. So, if we have this figure, alam naman natin na pag left endpoint, tayo nag-start sa pinaka-left or lower limit. So, syempre, pagka right endpoint na tayo, pinag-usapan natin, we start with the rightmost or yung ating upper limit. So, with this, hindi ka dito mag-start, dito ka na ngayon mag-start sa 10. So, intersect mo ngayon yung end yung end nung yung upper limit, and then with the curve. And then, ipaproject mo naman ngayon papuntang left sa halip na papuntang right. So, again, project natin siya papuntang left, and then baba ulit to meet that next interval. And then, again, ganun naman ulit siya. So, parang parang pa-mirror image lang nung idea natin ng ating Riemann sum for the left endpoint. Okay? So, ganun, and then you have to end up here. Okay, so meron din tayong 5 dyan na partitions. Pero mapapansin nyo, di ba? When we use right endpoint, we tend to have a lot of overestimates here. Okay? Unless we use the left endpoint where we have this a lot of underestimate, diba? Kasi basically, we're just trying to find the area of the rectangle. So basically, pag ito, we can say na overestimate. Pag ito, underestimate, no? Pero sa portion na to, syempre, this one is an overestimate. Pero since maliit lang siya, ano siya, mas naging mas nako-compromise itong ating underestimate yung ganong setting. Now, this is the right endpoint, and siguro meron ako idea na I will not be using f of 0 in this computation since f of 10 ako mag-i-start, diba? So, basically, na-compute natin kanina, binura lang natin. So, diba, we have here yung ating Riemann sum or the area using our right endpoint. So, I'll be using siguro yung ating a sub r na lang. So, that is equal to your, start tayo sa pinaka upper limit. So, that is f of 10. And then times natin sa ating norm, so that is 2 plus f of 8 times 2 ulit plus f of 6 times 2 ulit plus f of 4 times 2 ulit, and then finally yung ating f of 2 times 2. So ngayon yung ating f of 0 hindi natin siya isasama kasi we're starting with the right endpoint. In the same way that we did not include f of 10 dun sa ating left endpoint. So hopefully na malino to sa inyo, no? So, I think na-compute natin yung mga values ito, pero syempre, since nabura natin, compute na lang ulit natin, no? So, for our f of 10, so f of 10 would be 10 cubed minus 2 times 10 plus 1. So, that's 981. So, you have 981 times 2. So, that is for our area 1. Okay? Or pwede naman itong area 1. So, ito maging area 5 natin. So, depende yun sa inyo, no? And then, plus for the next area, we have f of 8. So, that is, computing ko na lang ulit, no? I think that's 497. Tapos, times natin sa 2. So, 497 again, times 2. And then, we add f of 6. So, that is 6 cubed minus 2 times 6 plus 1, which gives me 205. Okay? Times 2. And then, for f of 4, so that is 4 cubed minus 2 times 4 plus 1. So, that is 57 times 2. And then finally, what we have here is, I think that is 5 times 2. Okay. So, that's it for our area. And then, we just have to add all of this. And then, if we try to add all of this, then makukuha natin yung ating area using the right endpoint as 3,490 units squared. Okay. So, kung mapapansin nyo dyan, the area using the left endpoint. So, ito yung ating area sa left endpoint mo. Area sa left endpoint equal to 1,530 units squared. So, we could say that yung area natin sa right ay mas malaki sa area sa left. Now, usually, ating area is pagka left endpoint is underestimate yan. Pag area to the right, area right endpoint, overestimate. Pero syempre, iba yan. Depende sa graph pa rin, no? Pero usually, ganun siya. Kagaya nito, ito kasi is increasing from left to right. Pero halimbawa, meron tayong area, let's say, decreasing siya from left to right. So, ganito yung ating figure, no? And then, I want to find the area from A to B here. So, di ba, alam natin na if you try to use left endpoint, so dito tayo mag-start, and then, let's say, we have 1, 2, 3, 4. Let's say, 5 partitions ulit. So, di ba, ang magiging gagawin natin is ganyan siya. Okay? So, just intersect that. Finally, end up here. So, mapapansin nyo, left endpoint siya, pero this one is an overestimate. So, basically, depende pa rin siya sa ating curve na tinitingnan. Kasi once na we have a curve that is decreasing, and then we are trying to find that on the left endpoint, then we are expecting to have this overestimate. But if it is increasing, and then we're trying to find the area from the left using the left endpoint, then that should be expected to have an underestimate area. So again, how do we deal with this, no? Kasi syempre, ano yan magkaiba yung area. So ano yung i-report natin? Syempre depende sa tanong. Kung hinahanap is using left endpoint 1530, pagka right endpoint 3490. Pero how about if we're asked to find the average of left and right? So kung mapapansin nyo, diba, may left and right tayo dun kanina. So let's just take the average. So in short, kuhanin lang natin yung ating area sa left and then area using the right endpoint and then divide it by 2. So that would be your average. Okay? So if we try to find the average, so that would be something like, burahin na natin to siguro kasi alam niyo naman to, no? Okay. So pag average, so what we have here is your average is equal to area average is equal to the left endpoint plus the right endpoint area divided by 2. That is 3,490 plus 1,530 divided by 2. So our average area using the right and left endpoint would simply be equal to 2,510 units squared. Okay? So this is your average area. This is your area using the left endpoint. So, dapat expect nyo na kapag average, nasa pagitan niya nung right and left na area, no? And this finding the average area of the left and right endpoint is actually what we call the trapezoidal rule, which is not actually stated in your handout. So basically, kapag ginawa mo yun, what you're doing is trapezoidal rule na, hindi na siya Riemann sum. So parang extension siya nung ating Riemann sum. So ano ba yung trapezoidal rule? So 'di ba you already know how to do this Riemann sum using the figure that we have. So for example, ginawa natin yung ating average. Ano ba yung tsura ng average natin? So using this same figure, kunwari ganyan siya, no? So ang ating Riemann sum kapag average, ang itsura niya would be something like this, no? Di ba meron tayong, kailangan 5 partitions. So 1, 2, 3, 4, 1, 2, 3, 4, isa pa. Okay, so ito yung ating yung mga boundaries natin sa left and then sa right. So pag sinabi nating trapezoidal rule or the average, so instead of having the rectangles, we'll be creating trapezoid by connecting each point with the intersection of the x value. So ganyan mangyayari, and then this one is dito. Okay, this one is intersected here, so dito siya. And then basically ito is dito. Finally dito. So kung mapapansin nyo, gumagawa tayo ng mga trapezoid natin, yung mga ganyan-ganyan, 'di ba? Kaya siya tinawag na trapezoidal rule, which kung mapapansin nyo, mas ano siya 'di ba? Mas parang mas accurate. Kaya what we have to do is to always take the average of your right and left Riemann sum when reporting kapag walang sinabi. Pero syempre, in your case, laging sasabihin kung ano ba siya, area to the left, area using left endpoint or area to the right. I mean, right endpoint. Lagyan ko area to the right. So, yun lang. And then, there is a formula for the trapezoidal rule, or which in this case, you can directly find the area of the average without finding the left and right endpoint. So, ang idea lang naman sa kanya is you have to take your lower endpoint. Okay, so we have b minus a over n. So, ganun pa rin siya, no? Yung delta x natin. Pero, i-multiply natin to ngayon sa your f of a, okay? And then your f of b. So, ito yung ating lower and right endpoint. And then, you have to take twice of every area that you have in between a and b. So, parang, let's say we have c1 plus 2 f of c2 plus 2f of c3 and so on. Okay? And then, of course, you'd have to divide this by 2. So, we have 2n here. So, ito yung parang formula niya. Kasi, it makes perfect sense. Bakit ba ganun? Kasi, kung halimbawa, we have to take the average of this area left and right, alam naman natin na may nag-overlap dito na values which is ito po, itong f of 2, f of 4, f of 6, f of 8, kung natatandaan nyo, no? So, ito yung reason kung bakit meron ditong 2, kasi na-add sila, nag-overlap. And then, pero yung ating a and b, di ba, hindi sila mag-overlap kasi right and left lang to pinag-add natin. So, with that, since nga trapezoid siya, so ang area ng ating trapezoid, di ba, we have b1 plus b2 over 2 times height. That's why, this is the reason why we have b1 plus b2, and then divide natin siya sa 2. Siyempre, yung ating height would be the norm natin, or yung ating length of the interval. Siyempre, assume natin na yan ay constant. So, yun yung ating trapezoidal rule. Though, hindi naman talaga ito yung ating concern dito, which is the Riemann sum naman talaga. Pero just to give you an idea, why is it called the trapezoidal rule when that is the average of the Riemann sum. So, yun lang. Hopefully, nag-gets nyo yung ating first 3 examples. And I'll do the next ones here. Actually, same lang naman sila. Iba-iba lang. Left, right, endpoint, and then average lang. Okay?